today I'm welcome you all to this mini custom webinar, volume 11, volume 21. Our today's webinar will be in new era of geospatial technology, surface analysis via SuperMap GIS. So today is 31st of January 2022. Time is 3 p.m. GMT +6, and this is Dhaka time. And today's webinar is totally free, and you will get all of the materials after completing this webinar, and hope you will enjoy today. So first of all, let me introduce SuperMap to you. SuperMap started its journey from 1997 from Beijing, and the founder of SuperMap is Dr. Eshan Zhang. SuperMap has traveled more than 24 years of GIS software journey with more than 4,000 employees all over the world. SuperMap has more than 1,000 partners in 30 plus countries all over the world, and also have 38 branch offices and subsidiaries. SuperMap, SuperMap has mainly total 5 main key technology. So these are like big data GIS, AI GIS, 3-dimensional GIS, distributed GIS, and cross-platform GIS. So in today's demonstration, we will demonstrate a new era of geospatial technology, surface analysis via SuperMap GIS. And me, Ubaid Rahman, as a SuperMap technical engineer from SuperMap Asia and Oceania Center. So let's go on our live demonstration for today. We will use SuperMap Desktop 10i version 10.2, and you can download directly from SuperMap website. Here you can see this is SuperMap website to download the software, and you can download also other software like SuperMap iServer, iPortal, iPortal Data Store, iClient, iMobile, and all of the things you can download for free for limited trial version for 90 days. And after installing the software, it will automatically active, and you can run every analysis you want. So this is SuperMap Desktop, and here you can see I'm just introducing you the software interface to you. Here, this is our this is the menu bar of SuperMap Desktop 10i. These are panels. Here you can see the workspace manager, where you can like store all of the data sources, and also you can save the workspace. And under the workspace manager, you can save all of your maps, layouts, scene, diagram, and also you will have resources like resources for point dataset, resources for line dataset, and also resources for polygon dataset. You can save all of the things here, and all of the layer will appear in our layer manager. And this start tab contains many more things, like you can open your dataset from your workspace. You can add a new workspace. You can add datasets from file data source. These are the file data source, and you can also import dataset. You can extract data from a specific data source or append to records in a batch. And you will get online maps, like SuperMap supports the page maps. For example, OpenStreetMap or Map Vault. You can explore more. Here you will get some sample maps to explore some analysis. Like here you can get like 3D hillshade map, travel map, digital line graph, North America climate map, Boston with mapbox style heat map. It's actually the hotspot map, and you can get also the grid aggregation map. Okay, and then here are some other things. Here you will get some sample scene. Is actually the 3D dataset like city model, oblique photography, underground pipeline, mobile traffic sketch, etc. Okay, so that's all the start tab, and here this is the data tab, and we also have the data catalog manager. Here you can connect all of your folder. You can add the folder connection and directly open your dataset from here. Like here, this is like, for example, I'm opening one dataset for Bangladesh. So this is Bangladesh data, listing.shp. I'm just opening this one. This will open in our window. Okay, so here you can see, very much easy. So for now, in today's demonstration, I'm going to cover some surface analysis to show the analysis of 3D surfaces and also the plane surfaces, and also for our the built up areas, the built surfaces will be shown in our 3D analysis. Okay, so this is our software. And first of all, what we need to do, we need to import our dataset to our software. To do this, I'm going to SuperMap Desktop. I'm just closing this dataset. Okay, so first of all, what we need to do, we need to add one data source to import our surface data. Okay, so I'm just right clicking over here and select new file data source. And then I'm going to my folder where I kept all my data. And we will just write a name for this data source, like surface analysis. Okay. You can select the file type from here. There we have two types of data source. One is UDBX and second one is UDB. So this is default, and I'm keeping this default data source format. Then click on save. Okay, we got our data source surface analysis, and now what we will do, we will import one raster data, which is our surface data, on which we will analyze the tool sets and we'll see the result. So just right click over here and select the import dataset, this one. Okay, so we can import the dataset from different sources. So I'm just importing from my folder. The import dataset window, here you can see, this is one this window contains the options to import all of your data, and this is the add file button. I'm clicking here, and here you can see I have one SRTM digital elevation model data for the region of Chittagong Hill Trek, which is a hilly region in Bangladesh. So I'm selecting this one and opening this. And after that, you will get some options like you can encode this data as many more format like DCT, PNG, LGW. So the default format is PNG, and you can select the image type actually, the raster data type. Here you can select the image, or you can select also raster. So for today's demonstration, as we are going to cover the analysis for surface analysis for surfaces, raster surface, we will select raster. And this is one single band image, and we can select the reference file, but for now I'm not doing this. And this is the source info where the data located. Okay, this is the path, and the chart set is ASCII. Okay, so I'm just clicking here import. Okay, so here you can see that our data set imported in our workspace. and we can save the workspace. So first of all, I am saving my workspace. Just right click over here, save workspace as. We'll select this card, and I'm selecting the file name here. So this will be our surface analysis workspace. Okay, so I'm saving this. So this is our workspace. Actually, why we need to save our workspace? We need to save our workspace to save all of the things. Like we create one map, we create one layout, scene, or diagram. So all the things saved under our workspace. So we need to save our workspace. Okay. After saving first time your workspace, the workspace will save automatically while you are working in your software. Okay. So first of all, we will just import this data, just like we will see some surface analysis. So first of all, here you can see the special analysis toolsets are available here, and under this you can see the surface analysis. Okay, so here you will get a lot of analysis option, like here you can see the extract isoline, terrain calculation, okay, then visibility analyst, then surface measure, a lot of tools available here. So we will see some example how to do all of the things and see the result. Okay, so first of all, we will create one ortho image or hillshed to see the hillshed output of this digital elevation model. So I'm just right clicking over here and adding to a new map, or you can just close this one. You can just select this and drag it over here and release the click. So here you can see the dataset here. You can change the color table. Just right click over here and you can select the set color table. Okay, here you will get all of the color set to change the color by your study purpose. So I'm not doing this one. And as we will create some special analysis and surface analysis, I will just create one hillshed image. So I'm selecting this, and as this is our data set, we will just select our resultant data set as hillshed result. Okay, so I'm clicking here. Okay, this is on our result of hillshed. So if I just open this here, okay, now you can see the result. So if I just go to set color table, I'm changing the color table from black to white. Okay, so here you can see the hillshed effect of this surface, of this 3D surface actually. Okay, if I open just change the layer order, I'm just altering this SRTM image. Just right click over here and go to layer properties. Then if I change the transparency like 50%, here you can see the output. Okay, this is looks like the real ground or real surface. Okay, as like a 3D effect. So this is one type of surface analysis, and here you can see they have a lot of surface analysis. Like you can select the slope analysis, you can calculate the aspect, you can calculate the profile. So we will do all of the things for our 3D data, and we will create 3D analysis for this surface. Okay. So first of all, I'm going to my presentation. So to do the 3D analysis for this surface, we need to add this dataset to a scene. So we need to open one scene layer. So I'm going here, and what will I do? Just right click over here and select the add to new spherical scene. Okay, so this will create a scene layer for our dataset, and we can do the 3D analysis in our scene layer. So here we'll get two options. One is you can add both, like you can add your digital elevation model data as terrain, or you can, and also you can add it as image. So I'm adding both and clicking OK. And if I just right click over here and jump to layer. Okay, so here you can see this is our layer, and if I just tilt the layer, you can see the edge of this hilly region. Okay, you can see the altitude of these hills very clearly and very easily. Okay, so what we are gonna doing like this? You can see that you can change the visibility, you can change the group, you can select, you can measure all of the things from here in our 3D data. You can add your cache file, and also you can add the online maps. So here, for example, you can open the OpenStreetMap in our 3D view. So I'm not doing this for time being. And here you can see we have 3D analysis tab, and we have a lot of analysis option here. You can see the spatial analysis, surface analysis, all of surface analysis. So the first one in our presentation is isoline analysis. So what is isoline actually? Isoline actually represents the result by overlaying it on the DEM data in a 3D way. Okay, so this is the actually the control line showing the topography over the areas, and if I select here, that isoline analysis is available here, and if you select here, one analysis tab will open, 3D spatial analysis tab, and from here you can select any of 3D spatial analysis for your surface. Okay, so first of all, what we'll do, we will just use this isoline analysis, and to select isoline analysis, you have to select the region for which region you are interested to analyze the isoline analysis. Okay, so if I select this region, and here you can see the plus button to select your region, select this plus button and draw a polygon. So I'm drawing here, and it will analyze live. Okay, so here you can see the live analysis. Okay, and once you complete your drawing, just right click, and this is the complete of isoline analysis. And here you can see the contour line in 3D. Okay, it's impressive actually. Okay, so this is one example for isoline analysis. You can select any of the region or any of, like if I select here, then you can see here we get two contour maps. One is here, and it will save automatically in our isoline analysis. And one is here, this one is here, and if I select this one will be here. Okay, so this is totally impressive, and you can change the color texture from here. Like you can select any of the color scheme from this color table. Okay, you can select the blend mode to texture filtering or contour. Okay, this is the contour mode. You can select the texture filling. This is the texture filling mode. you can also select the blend mode again. So this one is blend mode. This one is combining two mode like texture and also contour. And this one is blend mode. So I'm again changing the color table for here, and there's a lot of random color available. Okay, so this is one example for isolant analysis in 3D surface. So the next one here is slope and aspect analysis for our tutorial today's training. Actually, slope is the gradient or steepness of a unit of terrain, and the aspect identifies the downslope direction of the maximum rate of change in halo from each cell to its neighbors. So it's actually showing the direction, and the slope is actually showing the gradient or steepness of a terrain or a elevation model. So just for now, here you can see the slope and aspect analysis here. And if I select the slope and aspect, and then if I just select one region, just like add the region from here. And once you complete your drawing your region or area, just right click. Okay, so here you can see the slope of all the tables, and you can change the color table from here. Okay, here you can see the slope area and also the aspects, and you can add flow actually, that the directional flow actually. If I select this, check this flow option, and you can see the flow actually. Slope and aspect. Okay, so here you can see the 3D flow. Okay, these are the flow. These are the flowing, and you can identify the steepness and also the direction of this slope by this flow option. And if you want to see only the slope, you can select the only slope and see the only aspect. You can see the only aspect from here. This is the only aspect, and you can select the both from here. Okay, this is the combination of flow and aspect analysis. Okay, so this is our data set. And the next one is flood analysis. So what is flood analysis actually? It uses to simulate the flooding process actually, the simulation of flood water, the flooding process over a duration of time with the specified speed and within the maximum and minimum elevation. Okay, so here if we go to our data set again, we will create one of flooding analysis for this, and here you can see we have the flooding analysis, and also we have this one here, and we need to select the region, like if we select region from here, like this region. Okay, just select the region, add, and select draw a polygon. Okay, and once you complete your polygon, just right click. So then here you can see the flooding analysis is going on. So here you can change the altitude, maximum altitude, time frame. I select the time as 5, and if I select the loop and again run this one, here you can see the flooding and flooding of this region are showing here within this 5 seconds. Okay, and it's using the loop, so it will do again and again, and you can stop this by using this option. And also you can change the color of this water. If I select the color dark and again run this, so here you can see the flooding analysis. Okay, so these were the surface analysis, 3D surface analysis actually, and also the 2D surface analysis. And then what we will do, we will use another data set for our analysis, which will be our which will be a 3D surface analysis in a built-up area. So let's move on and just save this scene as there, and also save this one, and save this data workspace. They are also actually saved automatically. Here you can see workspace has been saved automatically. Okay, so what will I do? I will open another data set for your reference, which will be our 3D analysis data. Okay, so we'll open our 3D scene actually, which will be our CVD. Open the scene. So this is our 3D scene layer, and here you can see one CBD, which is Central Business District. And by using this scene, 3D scene, we'll show some 3D analysis, how you can do the built surface analysis. This is the built up area, and okay. So first of all, this one is our 3D model data, and this one is a 3D scene layer. And what will you do? We will just go to, like, first of all, we will go to for visibility analysis. So visibility analysis, often used in 3D analysis, this function is used to determine whether certain location in a 3D scene are visible to the observer location. Okay, so if I just go to select the visibility analysis from here, here you can see visibility analysis. And if I select one point, selecting point, so if I select point from like, okay, control layer. Okay, if I select one point from this portion, actually, if I select one point from this point and the ending point, if I select like here, one here, and also one in here, one in like this area. Okay, so then you can see that the analysis shows that from this point we can see these buildings or these areas, but we cannot see this this portion. So the red line indicates the invisible areas, and the green line indicates the visible areas from this point. This is actually the viewshed analysis. sorry, visibility analysis. Okay, then what we will do, we will go for the viewshed analysis. Viewshed analysis is actually this function is to identify all the visible and invisible range in the analysis area of a scene actually. So first of all, if I consider like this road or this point from this 3D scene, if I consider this point and I want to analyze this area by viewshed analysis, I want to see which portion of this area are visible from this point. Okay, so I just select this viewshed analysis from here, and from this I'm selecting the viewshed, adding the point of viewshed, and I'm selecting here. And if I select the range and okay, so then I'm done, and here you can see that the analysis showing the green portion are visible from this portion, this point actually, and the red portion are non-visible from this point. So this data is very effective, and this analysis shows the planning for our different 3D or different city areas. Okay, so this is very quite good and very easy to do for our data set. And let's move on to our next analysis, which will be our sunlight analysis. So what actually sunlight analysis do, that sunlight analysis is used to calculate the duration of sunlight in a period of time within extent defined by the latitude and longitude. So if we consider one region, if we consider one area to do the sunlight analysis, we can see the amount of sunlight and their duration in a specific context. Okay. Then what I'm going to do, I'm just going to my software here. You can keep all of the things here, or you can delete your scene from here. Just right click over here and delete. Okay, I'm deleting all of the things. Okay, so what will we do now? We will create one sunlight analysis, for example, for this region or this region. You can select this area. So this area actually, this portion, to see the sunlight analysis result. Okay. So we are going here, and you can see the shadow or going to 3D analysis. Here is the shadow analyst. Okay, then I'm selecting this one and selecting the area from here. And if I done, just right click over here. So here you can see the sunlight analysis result. Very detailed and very clear. Okay, the amount of sunlight, and here you can change the time, like you can change the time for evening or morning time, and also you can perform the analysis by using your time sets. Okay. So you can check the mouse search sunlight option. Here, if I just select this one, here you can see daylight rate, this one showing. And here you can see the daylight rate is 62%. This one is daylight rate 38%. This one shows a daylight rate 54%. And this one shows us daylight rate 46%. So there have different daylight rate for different point of your region in sunlight analysis. So you can determine the area where you are going to build one new business or anything. So here you can see the smooth rendering of sunlight analysis. And if I just check this one, this is 154%, it's 46%, and on and on. Okay, so this is very much easy and very impressive. Okay, so our next analysis, we are going to the profile analysis. Okay, the profile analysis actually shows the change of elevation along the line or along the section. So we need to draw a cross section within our areas where we want to see the profile of these areas. So I'm going to, in my SuperMap, and here you can see the profile analysis tab. And if I select this one, and if I just select draw a cut line from here to here, okay, you will get one result. You'll get, yes, this one. Here you will get one new window to see the result of your profile analysis. So here you can see that the altitude level is decreasing from this point to this point. Here you can see the altitude line. Hey. So this is actually the cross-section line, and this is showing the profile analysis of this region. And what will we do in our last analysis is Skyline Analysis. Skyline Analysis is the function which will allow you the generation of boundary between the building tops and the sky from the observer point. Okay, so if we just go to our data set, and if we select the Skyline Analysis from here, and select this one. So if I select points from here to here, and we can do other analysis like multiple view shed analysis, openness analysis, shadow analysis, video projection. We can project one video from here. So I'm not doing this one for now. Here you can see the video projection. Okay. So everything is possible in SuperMap. You can do every single surface analysis in both 2D and 3D in a single platform. And this is very much impressive to do, like sunlight analysis, or I'm just getting this video analysis. Okay, these are the sunlight point of this area. And also other analysis I've shown before. So if you have any comment or question, please write down in our Q&A section. So these were the total of our today's demonstration. You can download all of the materials of today's session by just scanning this QR code, and if you submit the screenshot of your result in a PDF file or what's called MS Office Word file, by 6th of February, you will get the training certificate from SuperMap. So it's very much easy to do all of the things I've shown you. That you need to just download the materials and perform by yourself in your PC or computer, and then you just take some screenshot of your result in a Word file. Like if I just open one Word file and just try to name, email, country. Okay, and then just paste all of your result and task by screenshot, taking a screenshot. Like if I take one screenshot from this portion, okay. And then I'm just pasting it over here. Okay, this is my result 1 or Skyline Analysis result. By this method, you put all of your results here. Okay, then you just save it as a Word file or a like PDF file, then submit these results within 6th of February. After that, you will get the certificate by submitting the result. So this one is very much easy task, and I hope you all can do this one. And you can scan this, and you all will get the materials of today, like software, the training recording, and also this data set, and also this presentation. So for today, thank you everyone again for joining.